Hey, all you cool cats and kittens, it's your favorite history teacher back again with another historical video. Today, we finally start some actual content. Um, the Enlightenment. Well, today we're starting a new unit. And so let's get into it. Unit 1. And where's my share? There we go. Okay, so chapter 3 in your textbook, The Enlightenment and Revolutions. This is unit 1. Some essential questions you'll need to answer these. Why do new ideas often spark change? And how do new ways of thinking affect the way people respond to their surroundings? So these are some questions we should always have in the back of our heads when we're taking notes, especially during the Enlightenment where this shift of knowledge happens. But that shift of knowledge happens a little bit before, too, something called the scientific revolution. So, right today, this is what we're going to talk about: the scientific revolution. Chapter 3, lesson 1. All right, so that was your warm up. Objectives. Students will be able to draw conclusions about how the development of new technology and new theories became the foundation of the scientific revolution. We're going to summarize the contributions of women scientists during the scientific revolution and compare and contrast inductive and deductive reasoning to understand the scientific method. All right, using your noggin. It looks like a lot. There is a lot. So in the Middle Ages, many educated Europeans took great interest in the world around them. However, these natural philosophers did not make observations of the natural world. They relied on a few ancient authorities like Aristotle for their scientific knowledge. Renaissance humanists had mastered Greek and Latin, which gave them skills to access newly discovered texts of Archimedes and Plato. These writings made it obvious that some ancient thinkers had disagreed with Aristotle and the other accepted authorities of the Middle Ages. Technical problems that required careful observation and accurate measurements served to stimulate scientific activity, like calculating how much weight ships could hold cargo. Then the invention of new instruments like the telescope and microscope made fresh scientific discoveries possible. Above all, the printing press made new ideas spread quickly and easily across Europe. Math would be promoted in the Renaissance by rediscovery of works of ancient mathematicians, and mathematics was seen as the key to navigation, military science, and geography. Renaissance thinkers believed that math was the key to understanding the nature of things in the universe. Thinkers like Nicholas Copernicus, Johann Kepler, Galilei, and Isaac Newton were all great mathematicians who believed the secrets of nature were written in the language of math. Interesting. After studying and sometimes discarding the ideas of ancient mathematicians, these intellectuals developed their new theories that became the foundation of the scientific revolution. So here you have Aristotle, Archimedes, Plato. Then we have Copernicus. Who are the other guys? Kepler, Galileo, and Newton. All right, self-centered. During the scientific revolution, discoveries in astronomy led to a new concept in the universe. Breakthroughs advanced medical knowledge and launched the field of chemistry as well. Ptolemy was the greatest astronomer of antiquity. Using Ptolemy's ideas as well as those of Aristotle and Christianity, philosophers in the Middle Ages constructed a model of the universe later known as the Ptolemaic system. The P is silent. This model was geocentric because it places Earth at the center of the universe. So up until then, up until Nicholas Copernicus in 1500, everyone believed because they were told that the Earth was the center of the universe, and everyone believed that. In a Ptolemaic system, the universe is seen as a series of concentric spheres, one inside the other. Earth is fixed or motionless at the center. The heavenly bodies, or pure orbs of light, are embedded in the crystal-like transparent spheres that rotate about the Earth. The moon is embedded in the first sphere, Mercury is second, Venus third, and the sun is fourth. The moon is, I just said the rotation of the spheres make it, these heavenly bodies rotate around Earth and in relation to one another. The 10th sphere in the Ptolemaic system is the prime mover. This sphere gives itself and gives motion to the other spheres. Beyond the 10th sphere is heaven and where God resides. God at one end of the universe and humans were at the center. I mean, considering Earth motionless, when you step outside, you don't feel like you're moving, right? So Ptolemy, he had this idea that, hey, we aren't moving, but all these other areas are moving around us. So therefore, we must be at the center of the universe. It's not too crazy. In May 1543, Nicholas Copernicus, native of Poland, published his famous book on the revolutions of the heavenly spheres. Copernicus was a mathematician, and he thought that his heliocentric or sun-centered concept of the universe offered a more accurate explanation than the Ptolemaic system. In his system, the sun not the Earth, was at the center of the universe, and the planets revolved around the sun. The moon revolved around the Earth. Moreover, the movement of the sun and around the Earth was caused by the rotation of the Earth on its axis and the journey around the sun. Johann Kepler, a German mathematician, took the next step in destroying the Ptolemaic system. Kepler would use detailed astronomical data to arrive at his laws of planetary motion. His observations confirmed the sun was at the center of the universe and also added new information from findings. In his first law, Kepler showed that the planet's orbits around the sun were not circular, as Copernicus had thought. Rather, the orbits were elliptical, egg-shaped, with the sun towards the end of the ellipse instead of at the center. The finding, known as Kepler's first law, contradicted the circular orbits and crystal-like spheres that were central to the Ptolemaic system. So, two people come forward in the 1500s to discredit Ptolemy and his works that had been, I think it was around 100 CE. So for 1400 years, no one questioned this system, this model of the universe. And so here's Copernicus again and Kepler and their works. And these models are kind of where this scientific revolution takes place. Copernicus is heliocentric, Ptolemy geocentric. Got to know those. All right, GG. Scientists could now think in terms of planets revolving around the sun in elliptical orbits. Important questions remained unanswered, like how are planets made and how does one explain the motion of the universe? An Italian scientist first answered the question as the first European to make regular observations of the heavens using a telescope. Mathematician Galileo Galilei made a series of remarkable discoveries. Mountains on Earth's moons, 4 moons revolving around Jupiter, and sunspots. Galileo's observations seemed to destroy another aspect of the Ptolemaic conception that heavenly bodies had been seen as pure orbits of life, and now appear to be composed of material substance, just as Earth was. Galileo's discoveries, published in the Starry Messenger 1610, did more than make Europeans aware of the view of the universe than did the works of Copernicus and Kepler. But in the midst of the newfound fame, Galileo found himself under suspicion of the Catholic Church. The Catholic Church will order him to abandon the Copernican idea, which threatened the Church's entire concept of the universe. In spite of the Church's position, by the 1630s to 1640s, most astronomers had accepted the heliocentric idea of the universe. However, motion in the universe had not yet been explained. So this is why people never really challenged Ptolemy or the Ptolemaic system, is because the Catholic Church ruled everything in Europe. And so you have people who are afraid of their religion telling them what to do and what to believe. And you have scientists, these mathematicians, proving that, well, these places do not exist. We are not at the center of the universe. and therefore we must look at our place in the galaxy a bit different. All right, genius. So in 1642, Isaac Newton attended Cambridge University and became a later professor of mathematics there too. His major work was Mathematical Principles of Natural Philosophy, aka the Principia, for a shortened version and its Latin titles. In Principia, Newton denied the three laws of motion that govern the planetary bodies as well as the objects on Earth. Crucial to his whole argument was the universal law of gravitation. This law explains why planetary bodies continue their elliptical orbits around the sun. The law states in mathematical terms that every object in the universe is attracted to every other object by a force called gravity. This one law, mathematically proved, could explain all motion in the universe. Newton's ideas created a new picture of the universe. It was more seen as one huge, regulated, uniform machine that worked according to natural laws. Newton's concept dominated the modern worldview until Albert Einstein's concepts of relativity gave a new picture of the universe. That's Isaac Newton. And if you can think of gravity, think of when apples fall from a tree. All right, more science breakthroughs. The teachings of Galen, a Greek physician in the 100 CE, dominated medicine in the late Middle Ages. They relied on animal rather than human dissections to picture human anatomy. Galen would be wrong in many instances. So during the 16th century, that's the 1500s, a revolution in medicine began with Andreas Vesalius and William Harvey, adding to the understanding of human anatomy. By dissecting human bodies at the University of Padua, Vesalius accurately described the individual organs and general structure of the human body. Harvey showed that the heart, not the liver as Galen had thought, was the beginning point of circulation of blood. He also proved that blood flows through the veins and arteries and makes a complete circuit throughout the body. Blaise Pascal experimented with how liquids behave under pressure, led to the invention of the syringe. Robert Boyle was one of the first scientists to conduct controlled experiments in chemistry, which will lead to Boyle's law, and that volume of a gas varies with the pressure exerted on it. And Antoine Lavoisier invented the system for naming chemical elements still used today. Many people consider him the founder of modern chemistry. And there are all those people: Galen, Vesalius, Harvey, Pascal, Boyle, and Lavoisier. All right, women. So although scholarship was considered the exclusive domain of men, there were many women who contributed to the scientific revolution. Margaret Cavendish, a philosopher, and Maria Winkelmann, an astronomer, helped advance science through their work. Cavendish was tutored in the subjects suitable for girls of proper upbringing: music, dancing, reading, and needlework. She was not formally educated in the sciences. However, Cavendish wrote a number of works on the scientific matters, like being critical of the growing belief that humans, through science, were the masters of nature. In Germany, many of the women who were involved in science were astronomers, about 14% of the population. The most famous female astronomer in Germany was Maria Winkelmann. She married Gottfried Kirch, Prussia's foremost astronomer, became his assistant, began to practice astronomy under his tutelage. And there are those ladies. Mind over matter. So now new concepts of the universe brought about the scientific revolution, strongly influenced Western view of humankind. Nowhere is this more evident than the work of 17th century French philosopher René Descartes, not Descartes, Descartes, who brought a philosophical perspective to the natural sciences. He began by considering the doubt and uncertainty that seemed to be everywhere in the confusion of the 17th century, 1600s. He ended with a philosophy that largely dominated Western thought in the 20th century. The starting point for Descartes was the new system of doubt. In his famous work, Discourse on Method, Descartes decided to set aside all that he had learned and began again. One fact seemed to be beyond doubt: his own existence. Descartes emphasized the importance of his own mind, accepting that the only things in his reason said were true. From his first principle, I think, therefore I am, Descartes used his reason to arrive at a second principle. He argued that because the mind cannot be doubted, but the body and world can, the two must be radically different. From this idea came the idea of the separation of the mind and matter, and of mind and body. Descartes' idea that mind and matter were completely separate allowed scientists to view matter as dead or inert, not moving. That is, matter was something that was totally detached from the mind and that could be investigated independently by reason. Descartes has rightly been called the father of modern rationalism. The system of thought is based on belief, rather that reason is the chief source of knowledge. And that's Rene Descartes. The method. So during the scientific revolution, people became concerned with how best they could understand the physical world. The result was the creation of the scientific method, a systematic procedure for collecting and analyzing evidence. The scientific method was crucial to the evolution of science in the modern world. The person who first developed the scientific method was not a scientist, but an English philosopher named Francis Bacon. He believed that scientists should not rely on the ideas of ancient authorities, but should learn about nature by using inductive reasoning, proceeding from the particular concepts to general concepts. Bacon also practiced the theory of empiricism. As it says, knowledge is achieved through observation. Empiricism, coupled with experimentation and inductive reasoning, would ultimately lead philosophers and scientists to a greater understanding of the natural world. Before beginning his reasoning, scientists had tried to free their minds of opinions that might distort the truth. They start with detailed facts, proceed toward general principles. From observing those natural events, scientists propose hypotheses, possible explanations for the events. Then systematic observations and carefully organized experimentations to test the hypotheses would lead to correct general principles. Bacon, concerned with the practical matters as well as science, firmly believed in the scientific method. Bacon wanted science to benefit industry, agriculture, and trade. Bacon believed this human power could lead to be used to conquer nature in action. The control and domination of nature became an important concern of science and technology that will accompany it. And that's Francis Bacon. And that is the end of our lecture. Your homework is going to be where is it? Woo! There's the bell. Page 95, 2 through 4. 2, 3, and 4. So page 95, that's a big book. So page 95, 2, 3, and 4. All right. So that was a lot. I know I sped up at the end there. Remember, you write down what is in red, and to understand the enlightenment that's going to happen in the next lecture, I wanted to bring about some ideas that philosophers were now starting to think of, all because of this new age of thinking. And that is what the Enlightenment is about, this new age of thinking. So that's what we'll do next lecture. So hopefully you guys did enjoy that. If you did, make sure you hit that like button, leave a comment, subscribe, and I'll see you in the next one. Peace.